No, I'll start the welcome at
6:50. Sorry. Go ahead, sir, please.
Good evening, everyone. The Department of Civil Engineering, in association with ICI and ASC Student Chapter, is organizing a 4-day webinar. The topic for today's webinar is High Performance Concrete. Before we start the session, I would like to call Dr. Saeed Jalaluddin Shah, HOD of Civil Engineering Department, MESCE, for the welcome address.
A very good evening to one and all. On behalf of the Department of Civil Engineering, Mes College of Engineering Kuttipuram, I, Dr. Saeed Jalaluddin Shah, the head of the department, would like to welcome all the delegates and the participants of this webinar on high performance concrete, organized by the ICI Student Chapter and the ASC Student Chapter of the Department of Civil Engineering. We have had an overwhelming response of more than 100 registrations for this wonderful webinar. It's my pleasure to welcome each and everyone who has joined here for today's session. Before I proceed, I would like everyone to abide by the following guidelines for the smooth conduct of the online session. The attendees are requested to mute their mic and turn off their camera. Please do not present your screen in between. Participants are free to post their questions in the chat box by mentioning their name. The organizing team will present the questions to the speaker at the end of the session. The speaker will answer all the questions if the time permits at the end of the session. A recording of this webinar is prohibited. Certificates of attendees who have filled the feedback form will be emailed directly within 2 weeks. The feedback form will be shared during the course of this webinar. The online webinar recording will also be available in YouTube. If you need any assistance during the program, please use the chat box. Live YouTube streaming of this session is also done parallelly to accommodate more participants. Now, it's my pleasure to welcome our keynote speaker of the day, Mr.Shivaprakash Gangappa, Technical Manager, Admission System, First Rock Chemical India Private Limited, to deliver a talk on high performance concrete. Welcome, sir. Now, I invite Shibin Binshad to introduce the day's speaker. Thank you.
So before the introduction of speaker, I would like to welcome Dr. Irshad Abdulaziz, faculty for Civil Engineering Department and the AAC Student Chapter Head. I also take this opportunity to thank him for guiding us throughout for the achievement of our AAC Student Chapter. I would also like to thank him for providing us today's speaker. So now it's my pleasure to introduce our speaker of the day, Mr. Shivaprakash Gangappa. He is a senior manager in First Rock Chemicals India Private Limited. Mr. Shivaprakash has 25 years experience in construction industry in India and Middle East. He completed his MTech from C. Jayachamrajendra College of Engineering in Industrial Structure in Chemicals India. So I welcome him to address the session. So please.
Just 1 minute. I'm just okay. Where can I share my presentation? I'm just trying to look at the place. Just a minute, please. This particular system, we are not used to it. That's the only thing. Please excuse me on this particular delay.
It's okay, sir.
So there is a button on the extreme right bottom. Present now. We can just share the screen from there.
Just 1 minute. Your entire screen? Yes. 1 minute. Okay, if I go to present now, it asks about your entire screen. Is it the entire screen tab I got to go? Mathakuttu?
Yes, sir.
So if I go to entire screen, share. So I'm not successful. Can anyone help me on this, please? I'm a bit clear. What's happening? I could not able to share my screen here. Can anyone help me on this? Because when I go to that particular screen, it says share your entire screen. It's asking me. I said the share button is not getting dark. Only cancel button is getting dark. Can anyone help me on this particular system, please? Present now.
Click on that.
Sir, after clicking the present now,
Okay, after clicking the present now.
Your entire screen.
Okay.
The tab will be opened up, right?
Okay, tab is open.
So click on that tab.
Yes.
Now it's there.
I don't know, but what screen is being seen? No idea about it.
So we can see your entire screen, sir, now.
Okay.
You can go to the presentation, sir. Yes.
Just 1 minute. Is it okay now? I mean, the screen is visible now.
Yeah.
My presentation is visible on
Yes,
the screen. Okay.
Absolutely. Yes.
Okay. I'm really sorry about this because we are not used to this particular system, and that's the reason all these hiccups. The technology, we got to go along with the technology. This is where we lack in this particular thing. Okay. Let me start with my presentation. Probably this may take about an hour, maybe 15 minutes, 1 hour, 15 minutes. What is this high performance concrete? How do we differentiate the normal and high performance concrete? So how we could able to say one we should call it as an high performance concrete. So in order to overcome this, first I'll be touching upon the precast industry. So this is one particular industry which really could able to bring a difference in the market. So from there I'll be pulling on what is this high performance concrete and all this thing. Okay, someone confirm me whether my screen has changed. This is the second slide now.
Yes, sir. Yes, sir. It's changed.
So, the moment we get into the high performance concrete, why I have taken the precast industry for high performance concrete? The reason is because this is one particular concrete where in which the strength requirement goes like M60, M70, M80, even M120. This is where the requirement comes. And in addition to this, this also requires a high early strength gain also. So that's the reason I've just taken under high performance concrete where the precast industry is going to play an important role. What is this precast industry? Actually, this precast industry was first they tried somewhere in England. The place is called Liverpool. That was in 1905. A small segment where in which it was too difficult for them to go for a casting. So they said, okay, let's go for a mold kind of a system. Then we can't be implemented. So with this, the journey started with the precast industries. Then the technology advancement has taken the concrete into different shapes and sizes. Where which today, what precast industry, what we could able to see with this hyper, which is gone for a precast industry. Now, when we go for the features of this particular mixed design, when it comes to the question of precast industry. First of all, most of this high performance are precast concrete. The water cement ratio is going to be pretty low. The operating water cement ratio could be between 0.24 to 0.28. Probably that is one thing. Second thing, the high early strength is one more criteria where the people, they may look for 10 hours, 10 Newton per millimeter square, or 12 hours, 12 Newton per millimeter square. This is normally the normal trend what we come across. So how can we achieve this? So when once there is, we already know the moment we keep reducing the water cement ratio, the concrete becomes very sticky in nature. So how can we overcome this particular problem? So is it really practically possible to operate a concrete at 0.24 or a 0.28 water cement ratio? So we can produce a concrete in the laboratory level. Laboratory level, even there are cases, even we have went up to 0.16 also. With this 0.16, practically, is it possible for us to deliver the concrete at the site with having a retention and a higher strength parameter? Again and again, I keep reiterating this high performance concrete relevant to precast industry. The reason is because this high performance adding an early strength becomes much more complicated. For example, what kind of strength that we could able to deliver. So probably in next slides, I'll be discussing on what is the best strength, what we could able to deliver. Now, when we go to the design aspects or the influencing factor for this any kind of high performance concrete or a precast concrete. So maximum OPC content, what can be used is only 452 or 400 kg. This is what maximum cementitious content, what we can use as per IS 456. So with 450 kg to what level is a very question mark. When we cannot increase the OPC content, then how can we get the high performance concrete? So probably if we take the history, probably if you go to early ages of 1930s, so high performance concrete like high strength concrete was about M35. As probably we could able to come to late 1950s. So 1950s like M50, M55 has become a high performance or a maximum strength what we do deliver. And as the decade keeps going, and today what we are talking is an high performance concrete of M200 grade of concrete. But how can we deliver an M200 grade of concrete with a cementitious content of only 450 kg? So water cement ratio, how low you could able to take the water cement ratio to as low as possible. So here, the practical speaking, what is being used in the industry is a 450 kg of OPC or 440 kg. Then they use some fine reactive powder. What is this fine reactive powder? Really got to understand what is this fine reactive powder. The fine reactive powder can be of microsilica, because if you really look into the configuration, I mean the ingredients of microsilica or the fineness of microsilica. The microsilica's fineness is what the 1 kg of microsilica. Each particle of microsilica, if you spread and see the area, so 1 kg of microsilica can give an area of 18,000 meters square. So means to say this is highly reactive powder, and the surface area is so huge. So probably the replacement we cannot go more than 10%. If you go anything beyond 10%, the concrete becomes too sticky. Then the shrinkage values will be more. There are a lot of disadvantages. Even as per higher standard, we cannot go beyond 10%. But what is practically used is about 8% or a 9%. So that how can we the binder is the one aspect which is a major influencing factor for high performance or a high early strength concrete. Second thing, the ambient temperature. Ambient temperature may not be relevant with the high performance concrete, but high performance early strength concrete, yes, winter season, the cubes which are going to catch in the summer season, these two will give a huge amount of strength development scenario. So ambient temperature plays an important role. So before getting into ambient temperature, as I've discussed, the water cement ratio. So water cement ratio, moment we talk about the water cement ratio, there is no limitation, lower limit being mentioned in any of the standard. Only few concrete experts, they have mentioned what is minimum required is about 0.28 should be the lowest water cement ratio. Anything less than this, what happens? Even if you keep adding the powder, the hydration will not take place. That has been mentioned in few books where I've gone through. Even Brooks and Naveli, they also talk about this particular statement. But there is no rule that you have to restrict to this. If at all, if you have a room where which you could able to bring down the water cement ratio less than this, yes, it's possible. But whether the whole quantum of binder content, will it getting hydrated? That's a secondary question. But if at all possible to produce a concrete with water cement ratio lower than 0.28, yes, definitely, why not? So I will come back on the hydration process, whether 28 days is enough or 50 days, 6 days required or a 90 days required. So probably we may have to think on those particular aspects. So before getting into any of this, let's try to understand the chemistry of the cement first. Because whatever the high performance using is a cement. So in case of cement, what happens? So the cement do contains tricalcium silicate and dicalcium silicate. There are silicate compound and aluminate compounds. Normally, OPC 100%. I mean, if you take ordinary Portland cement, in case of ordinary Portland cement, this 85% of the contribution comes from silicates and balance 15% is a contribution from aluminates. Probably if you really slightly think about it, why can't we increase the aluminate and reduce silicate? Then what will happen? See, when once the cement has got a high affinity towards water, the moment cement comes in contact with water, immediately start hydrating. The very first compound which start hydrating is your aluminates. Aluminates basically brings the shape of the concrete, but it will never help you in contributing to the strength. Your strength contribution always comes only from silicates. So silicates maximum already we have about 85%, nothing more can we have, but we cannot produce a cement without aluminates also. Because silicates will take his own time to hydrate, but initially we are supposed to get the shape of the concrete, whatever the mold we have placed the concrete, to take that particular shape, aluminates are very required. So as a standard OPC, about 85% of silicates you will have, and aluminates will have about 15%. Now, what is an objective behind discussing this particular subject? The objective here is how can we trigger the silicate to have an early hydration and increase their strength generation strategy. So how can we improvise on this? So that's the first factor. Second one is how early we could able to take the concrete into the shape with the help of aluminates. So there are two ways we are supposed to trigger it, aluminates and as well as silicates. In this particular process, what happens? We all time, you got to mix it, you got to transport it, and you got to place it. So to do these three actions, what we call it as a workability. Workability is nothing but mixing, transporting, and placing. If you don't get such a sufficient amount of time, then what happens? This concrete is useless. It will not be in a position to use. So you need a retention in between. Once we get a concrete retention, then we are supposed to trigger this silicates to a greater extent, aluminate to a smaller extent, so that we could be able to get higher strength, which result in producing a high performance concrete. Now, let's come to the definition of what is high performance concrete. Performance, is it with respect to your compressive strength, or is it with respect to your durability of concrete? So how do you get high strength? The moment you could able to get a high strength, the performance is automatically goes better. That means if you do a chloride penetration test, for example, if you do a rapid chloride penetration test or a rapid chloride migration test, or if you do a pressure test using DIN 1048, which is a German standard, in all cases, the high strength concrete, which is more dense in nature, these concrete exhibit a better resistance to water penetration. The moment water penetration goes better, automatically what happens? It gives a better life of the concrete, which you are increasing the performance. So there are two ways of communicating your performance. One is performance with respect to durability, other one performance with respect to strength. What I'll be discussing today exclusively on strength, durability of concrete, probably that itself is a one more session. We may have to discuss it on some other day. Now, as I told you, we are in a position to use only the OPC cement, but OPC cement 450 kg is not enough. Now I want to add some more binder. So what other binders that I can add? So there are secondary mineral admixture in producing higher strength or high performance concrete. What is this mineral secondary cementitious material? You all know this one is brown granulated blast furnace slag, and second thing is fly ash. So these two are the secondary cementitious metal. We call it as SCMs. SCMs basically replaces by OPC. In case of a high performance concrete, it is not going to replace OPC. OPC we will maintain up to 450. Anything beyond this, because there is no codal provision or codal restriction wherein which you cannot replace. You can replace the fine aggregate with the secondary cementitious material. There are possibilities of doing this also. So in that way, such kind of provisions, the restrictions are not there in the codal in the mixed design. So what we do, we go with 450 kg of OPC, which is very badly needed for hydration of cement. Then we also go for a replacement of fine aggregate using GGBFS or a fly ash. So this is one way of operating mixed design as a high performance concrete. So thereby what happened, it also meets the requirement of IS 456 or IS 10262. Otherwise, this concrete cannot be used. This becomes part of a research kind of a job where which practically this cannot be used. So in order to incorporate this secondary cementitious material, first of all, we should know its behavior. What is the behavior of this? If we take a fly ash, probably you could able to see two graphs here. One graph with yellow line, other graph with the green line. So green line is an OPC concrete, same mixed, same, no change. We have used about 400 kg of OPC cement. Sorry, yellow line is the OPC cement. And the blue line is 300 kg OPC and 100 kg fly ash. That means I've replaced it by 23 or 24% of cement. The initial days, what happened? Your OPC concrete, which is yellow color, that will give you a higher listern. But this concrete with fly ash will give you lower stern. But as the age goes, at the 90 days, what happens? Your fly ash concrete and OPC concrete gives a same compared to your 100% OPC. So one thing we for one full year, definitely with the replacement of fly ash is going to be better. But the problem is we don't have so much time. So how can we bring it down? The break-even point, is there any possibility to bring it down? The next replacement is you can go with the GGBFS. In case of GGBFS, what happens? So your break-even point is on 28 days. So the advantage here is I can further squeeze down the water cement ratio. So thereby what happened? I can take this green line to, yellow. This green line, I can just initial days, we can take it to yellow line. So up to 25 days, it will be on par with the OPC. Then beyond 28 days, definitely OPC plus GGBFS concrete will be better. But what is the amount of replacement we go? In case of fly ash concrete, we went with 300 kg OPC, 100 kg fly ash. But in this particular case, the graph what I'm showing, this is 50% replacement. Means to say 100 kg of cement, sorry, out of 400 kg, 200 kg of OPC and 200 kg of GGBFS. So here, one point we got it very clear is your performance of the concrete in terms of durability will go better moment you start using secondary cementitious material, because your strength gain parameter will be much better going without in comparison with using only 100% OPC. So now, any high performance concrete, let us make our object very clear, saying that definitely we will go for a replacement of GGBFS or fly ash. Now, if I choose which one to go for, say which one, whether to go with the GGBFS, probably both material can be used depending on the availability. So there they prefer to go with the fly ash because fly ash is available abundantly. But if you come to down south like city like Bangalore, so Bangalore abundantly what is available is GGBFS. So in most of the projects in Bangalore, we come across GGBFS. Moment we go to Delhi, they use fly ash. The situation remains same in case of east also, where fly ash is abundantly available. But if you come to west like Mumbai kind of the city, where which you have a combination of OPC fly ash or OPC GGBFS, because both secondary cementitious materials are available abundantly. So this is what the total picture. What to choose, what not to choose is not our hand. We have to choose it according to the availability. Okay, so this is what the communication I wanted to communicate on this. But there is one more ingredient or one more secondary cementitious material, which is called silica fumes. Condensated silica fumes. CSF means condensated silica fumes. These are all byproduct of steel, but condensated silica fumes will not produce in India because the production of pig iron, from the iron ore to pig iron. So the process what we adopt a furnace kind of stuff, that in that process we only get GGBFS. But here, in this process of transforming iron ore to steel is a different methodology. So in that way, they get this condensated silica fumes. Condensated silica fumes are basically very high fineness in nature. So that's the reason right from day 1 to 365 days, the concrete which has got a condensated silica fumes will exhibit a better compressive strength compared to 100% OPC concrete. So now, For high strength concrete, for example, let's say my strength goes beyond 12 blends, OPC, GGVFS, and microsilica, or OPC, fly ash, and microsilica. Yes, the answer is yes. You have to use three combinations. Triplets you are supposed to go for, where in which this will help us to to produce a high performance or a higher strength concrete. Now, we have identified all the binder content. So binder content part, we are very clear. We have increased the fineness, the reactive powder to a greater extent. But who's going to support this? Who will make the concrete to operate at a low water cement ratio? This is the place where admixture plays an important role. What is this admixture is all about? Admixture is basically, which is in the liquid form, it's a formulated product. So the main property of an admixture is a water reducing property. What is this water reducing property if we talk about it? See, these are all the cement particle, what you could be able to see the left side picture. This particular picture has been, when the cement comes in contact with water, it reacts and the cement particle will join each other, and in the middle, there will be a water will get clogged. So now, the whatever water which get clogged, this water can be utilized for hydration of some other cement particle. But it just got clogged on the periphery of the cement particle. So I have to add an extra water to get the workability. Now, in case if I could able to free this particular water, then I don't have to add an extra water. So, moment you add admixture, these admixtures will form a negatively charged body on this periphery of the cement particle. Then these cement particles will repel each other. Probably in this particular slide, you could able to see the closed picture of it. The two cement particles will be negatively charged and it start repulsing. So this particular repulsive force is called. So where probably early 90s or early, but recent date, the new generation admixture, the fourth generation admixture, the second generation admixture, what they call it as a PCE base, which is polycarboxylic ether. These are all not the brand names. These are all the generic names of the chemicals. These chemicals, probably if you Google it out, you will find a number of explanation on these kind of chemicals. This polycarboxylic ether, which has got a water reducing capability up to maximum 40%. So with this 40%, we are capable of bringing down the water cement ratio to very low. In order to explain in a better way, for example, we have done a mixed design. The mixed design contains about 200 liters of water per cubic meter of concrete. So with this 200 liter, if you use this electrostatic repulsion type, which is SNF, sulfonated naphthalene formaldehyde or sulfonated melamine formaldehyde, if you use, you can bring down water from 120 to 150. Irrespective, even if you add extra dosage, the water reduction will not take place. But in case if you use a polycarboxylic ether-based admixture, then you can bring down the water from 200 liters to 120. There are chances even probably we may go less than this. So now here the choice of admixture. Whenever we go for high performance concrete, our objective is to use only polycarboxylic ether or an ester-based admixture. So that product selection has been fixed. And if you really go a little bit chemistry of this particular thing, there are different types of molecules are available. One is EPEG, one is MPEG, and VPEG. So let's not go deep into this because this again a one more bigger subject, how to choose molecules. What type of molecule is suitable for a high performance concrete? I'll give you one typical example. What molecule probably I will choose for a high performance concrete? See, these monomers has to be joined together with the process called, when you're joining these monomers, the process is called polymerization. To do the polymerization, there are certain additives we got to add to the monomers. What these monomers? Monomers are polyethylene glycols, PEGs. So these PEGs, when you want to join together, the process will happen only at a certain degree temperature. This MPEG kind of a material, it requires to be heated at 150 degree temperature. Only at 150 degree temperature, only if you could able to mix it, then what happens? These monomers will form to a polymers. So this process is called polymerization. This particular molecules are basically an ester based. Then ester based molecules, basically what it does is, basically it reduces the stickiness in the concrete. Now, for example, there is one more. Let me say, sorry, it has not been. A VPEG. In case of a VPEG, what happens? In the APEG, in case of a VPEG, the polymerization takes place in 45-degree temperature. Sorry, 25-degree temperature. Means you don't have to heat. Even with the ambient temperature, the polymerization takes place. So these kind of materials are really good in high water, but do VPEG-based PC molecule. So I'm just giving a glimpse of this particular product. Even probably if you have not if you have not understood this, it does not matter, because this is a chemistry behind this polycarboxylic ether-based admixture. Okay. Now, let me move on to one particular topic, then I'll come back to this. Okay. Now, these problems I'll come back. Now, let's go to the curing methods now. We produce concrete, everything fine. But how can, now for example, let us say I've used a total binder content maybe about 750 kgs to produce a high performance concrete. Most of the high performance concrete, your binder content will always be more than 1000 kg per cubic meter. Means to say, your OPC, GGBFS, and then microsilica, then alcofine. There are different raw materials what's supposed to be used as a binder. All binder put together, this will come something about 1000 kg per cubic meter. So when you go for such a high volume of powders, then what happens? The hydration may not take place in a given period of time. So how do we accelerate the hydration? So in order to accelerate this, we got to heat the process. How can we heat the process? So let's do one small, I'll just brief you on one small experiment. There is written 113, it is 123. Please correct yourself. There is one set of cubes which has been produced with same grade of concrete with a total binder content is about 800 kg, 1100 kg of binder content. And water cement ratio is 0.16. So you produce about one set of concrete which is going to be placed in the tank, curing tank, where we maintain a temperature of 20 degrees centigrade. Then again, probably I'll just to go to the next slide, it will be easy for me to explain. Okay, we can see the first set of cubes where the temperature has been increased from 0 to 20 degree. For throughout 28 days, we are going to maintain 20 degree temperature for the whole curing tank. The second set of experiment, 20 degree temperature initial, up to 7 days. After 7 days, we increase this to 90 days. Then we further continue for 9 days. From 9 days, again, we bring back the temperature to 20 degree. Then further, we will continue to 28 days. This is the second set of experiment. Third set is where initially 20 degree temperature. What I'm talking, this is the curing water temperature. Say if you take any of the ACT, accelerated curing test chambers, it has got a control on the temperature of the water which is being placed for the curing. So there you can maintain the temperature of the curing tanks, so that the water which is there, that will have a temperature of 20 degree for 7 days. Then after 7 to 9 days, 60 degree, 90 degree, then again come back to 20 degree, then it will continue for 28 days. The most important thing what to be noticed here is, we got to notice the last part. First 7 days is going to be your 20 degree. After 7 days, water temperature has been increased to 90 degree up to 9 days. After 9 days, we take out the cubes of water, then put it in the oven. Where the oven temperature is maintained at 200 degree temperature. After 200 degree, it will be in 2 days. Again, we'll bring back the concrete temperature to 28 degree and we will continue. Probably to understand, it takes a little bit of this thing. Probably in the next slide, you'll be in a better position to understand. You can see this, the composition. And in the concrete, we also use fibers. These fibers like 0%, 2%, 4%, and 6%. There are different percentage of fibers is being used. The 182 number, what you are looking at no fibers. This is totally a concrete immersed in water, where the temperature has been maintained 20 degree throughout for 28 days. But in between, we have increased the temperature for water temperature to 90 degrees for 3 days, so which could able to give a small increase from 188 to 190. But the cubes, which has been kept in the oven for about 2 days, so there is a drastic increase of the compressive strength of 250. What I'm talking, these 250 are megapascals, means to say Newton per millimeter square. Can we produce a concrete which is of a 250? Yes, definitely we can produce. In India, we have produced a concrete grade of M200, and it has been delivered to one of the projects in Mumbai. Very small quantity, because still we have not geared up with a high performance concrete of a strength of 200. That's what the consultant they worry about it. But the problem is the going at a higher strength becomes a greater challenge. But here, one thing what to be addressed is Mohan, the only one thing what we could able to address here is 6% with the fibers in the concrete, which could able to give 309 Newton per millimeter square. See, normally what happens in case of a normal concrete, fibers will not play any role in the development of strength. It will play a very important role in the tensile strength, not in the compressive strength. But when you go with this kind of temperature, and the ambient temperature is 25 to 20 for the whole day. This test was done for about 4 days. So maximum heat of hydration, the temperature, core temperature was 50. So the compressor strength, everything is very much perfect. The 28 days we got about 51, which was a M40 grade of concrete. We are getting about 51, perfect. And we have done an RCPT value also. The disadvantage of RCPT when you go with the 100% OPC is very high. The moment you are going to shift this with the secondary cementitious material, for example, you can see this mix high volume replacement of GGBFS, like whatever the 400 kg, 415 kg what we used in the first test. Second test we are using only 138 kg cement, and the balance is being replaced by GGBFS. So GGBFS, because of this, the peak rise in temperature could able to go only up to 44 degree. That's all. So here, how can we do the controlling of temperature? The controlling of temperature can be done in a different way. One is use a high volume replacement of GGBFS, or in addition to this, use a chilled water and maintain the concrete temperature less than 32 degree temperature, 32 degrees centigrade at the time of pouring. So these are all the few parameters where in which we have to follow it up. And once the concreting is being done, immediately we got to cover it with the polyethylene sheet. So that what happens, your ambient temperature and the core concrete temperature will be difference will be less than. Okay, let me not worry about heat of hydration. Let the concrete temperatures go beyond 70 degrees. What will happen? So there is one particular problem which occurs if you don't control this temperature. This problem is called DEF. That is delayed etching concrete. So this is one application where the metro goes below ground, where the TBM, so tunnel boring machine is running. We are supposed to use this particular segment. So this is one application what I would like to communicate, and this is the solution for TBM. You could able to see in the stockyard how the concrete has been casted in, which is placed, which is giving a RCPT value of 860 and compressive strength 12 Newton in 12 hours. Means M50 grade of concrete is meeting all the requirements. So in that way, this kind of concrete can be called as an high performance concrete. This is one application what I would like to communicate. And the next application is probably I'll just moving on, because these are all the same case histories with respect to metros. This is one more. You might have seen wind energy to deliver that. They will fix a kind of a fan in the wherever the wind speed is more than 4.5 meters per second. So in this particular case, what happens? In certain areas, the wind speed is available is only above 100 meters from the ground level. So when normally what happens, concrete foundation is going to be of your concrete, then above the concrete they fix a MS mild steel stem, then at the top they are going to fix the fans. But if the height of the fan should be placed at more than 100 meters, then this MS will not work because MS has got a oscillation moment. Because of this oscillation moment, the blades are getting damaged very often. And this is a very expensive wind energy generation to start with. But once it starts running, then the whatever energy you generate is going to be free of cost with the maintenance. But the installation cost for each unit is not, it runs in crores. So in that way, you can be using slip form method. So the one of the Spanish people, they are expert in this kind of an application. So they went for dividing that whole diameter of the stem to 3 parts, a precast unit. So height of this particular unit is about 20 meters. So the concrete, what is required is a free flow concrete. That means self-compacting concrete in 9 hours. This is what the requirement is all about. See, so well, but here the demand is different. So they're going to blow hot air for 3 hours. So we are supposed to get with this 20 Newton per millimeter square in 9 hours. Probably you can see this particular picture, how the casting will be taken for erection. Probably you have seen the first picture, the same case history what I'm delivering now. This is the case history. This is project which has been executed in northern part of Tamil Nadu, that's near Coimbatore. So this total height will go for a 120 meters. And look at the finish. If you precast units, you get a fantastic finish, provided your fluidity level of the concrete is very high. So what we got to maintain is how fluid the concrete is. That's more important. And it all depends on what paste content is being maintained in the concrete. So it's not limited only for this. It's also limited. You can also get into a building segment where the whole we can go with the precast. So all this high performance concrete has been very closely related to precast. Cast in situ I'm not taking because cast in situ has got some challenges. So precast, the implementation is very fast. So in case of, then I will come back to this. Look at this particular picture. Here, the top left picture is a casting. Once the casting is being done in the factory, this is the height of 18-story building, and this is the way finishing is being done. See, from casting to erection, this height of the building 18-story, it is just completed in 1.5 months. This particular project is Shobha Dreammakers in Bangalore. So the 12th month or 13th month, these buildings are handed over to the clients. So this is the level of fastness a developer could able to deliver the jobs to the client. And it's an excellent quality control. Absolutely, there is no problem at all. Probably, if anybody got a chance to visit this project, this is one of my favorite projects. It's really the quality of what is being maintained. It's an amazing quality which has been maintained. But look at the mixed design part. Initially, probably you can see the trial number 3. Initially, the project started with a 450 kg of cement. As I told you, this is the upper limit. They cannot go for this because here the requirement is 12 hours, 12 Newton per millimeter square, M40 grade of concrete. But on 28 day, we used to get about M70, M80. Water cement ratio is very low. They used to use 121, could be 0.26. But the challenge, what they said, the cost of the concrete was very high. Trial number 3, I'm just communicating. So there was a challenge they gave to us. Can this be replaced with a GGBFS? What percentage they can go for? And that to this particular experiment was done in the winter season. They said, winter, if you are passed, that means you are passed throughout the year. That's what the clientele requirement. So what we did, we went with a replacement of 25% of GGBFS. Oh, sorry. Okay, 25%. So 323 kg of OPC and 107 kg of GGBFS. Without compromising wet and hardened properties, still we could able to deliver 12 hours, 12 Newton per millimeter square. But this is a place where admixtures plays an important role. The selection of admixtures, the kind of molecule what is being used here, because here the triggering GGBFS is a more important one. So what kind of molecules are suitable for this kind of a GGBFS? This is basically the manufacturers of construction chemicals will have an expert on this particular thing. So now, because of this exercise, per a cubic meter of concrete, they could able to save something about 500 to 550 rupees. It looks very small. And per day, they produce about 200 cubic meter of concrete. Means to say something about 1 lakh rupee. They operate 26 days in a month. Means to say per month, they're saving 26 lakhs. And project is running for 5 years. So 26 lakhs into 12 plus 5. There's a tremendous amount of saving where client could able to witness moment they could able to replace this concrete with GGBFS. What is the other advantage? Heat of hydration came down to a greater extent. First thing, the durability of the concrete has gone up because it has been replaced by GGBFS. So all other, even though they were not need those things, they were happy with OPC, but still moment we go for a replacement, and these are all the advantages what they got it. So this is one live example, 30 kg, but still there are chances wherein which you could able to get 10 Newton per millimeter square in 10 hours. In case of the tunnel forming, what is this tunnel forming? The tunnel forming is a kind of a construction where the with this any questions please on this? Is that any questions on this? Chat box. Okay, let me have a look. You visit the chat box. Oh no, scroll. Okay, chats. Probably I'm not finding any questions on this. Probably what we can do, if at all any such requirements, is there, okay, there is one question, the Babu is, sir, is there any NDT test available to check the strength of high strength concrete? See, normally NDT tests are only an indicative. For example, if you go with a back rebound hammer, these are all basically will give only the what do you call, like, I mean, an indicative test. Most of the times, this back rebound hammer will not give an exact results when you go with a higher listed concrete. Probably their accuracy level is up to good, up to M40 or maximum up to M50 grade of concrete. When you go beyond M50, the back rebound hammers also probably will not get. That's the only instrument what is available with respect to NDT as on date. Otherwise, like, I mean, we have not come across any other. Normally, what they do, they go for a core test, which is a destructive testing. So for a given element, they go take a core. The core testing will be done. So that is a destructive test. It's not a non-destructive testing. So probably core test is a much more practical than getting into this thing. So back rebound hammer is the only possible base where which up to M50 grade of concrete to a certain extent I do accept the results. That's what Babu. So am I cleared your answer? Okay. Any other questions, please? Special labor training required for handling precast. Absolutely, I really appreciate this particular question, Fatima. It's really a fantastic question what you have asked, in fact, because normally concrete means people do have a tendency saying that the labor will handle this particular thing. It's no more labor-based concrete. So whenever we go for this kind of a special concrete or this kind of high-performance concrete, the engineer's involvement in this is very much required, and the quality control has to be done thoroughly on this, because concrete is a batch process. That means 1 cubic meter, 1 cubic meter. The maintaining consistency between the batch to batch is in the hands of the quality control person. So in that way, you are absolutely right. It requires a special training for the person who is the quality control. It also requires a special training for the person who is operating the batching plant. So as a whole, what question you asked is, yes, it requires a special training for all the people who are involved in high performance or precast concrete. any other questions, please? So what I can suggest is probably if you have any doubts or if you have any informations required, you can just send a mail to me or our Mr. Marthakuttu is there. Probably you can just request him, so we will revert back to you on this, any kind of a clarification on this particular side. So with this, I will end my presentation. Probably, okay, his email ID, probably you can see his email ID. So Marthakuttu Sebastian at fosrock.com. Probably you send your requirements on this particular mail ID. Definitely we will respond, and we have assistance to them on this particular stuff. Okay. So thank you very much. I just hand over the session to the host, please. Yeah, over to you, sir.
Now I request Muhammad Hashim PA, Chairperson of CEA, to deliver the vote of thanks.
Delivering to our most valued chief guest, Mr.Shivaprakash Gangappa, our HOD sir, Dr. Jayalanjan Shah, my colleagues and students. It's my privilege to propose a vote of thanks, opportunity to listen to thoughts and views on high performance concrete. I also take this opportunity to extend my deepest sense of appreciation to our HOD for his welcome address. Last, I thank all staff and students for their participation in this session. Thank you.
Feedback link is given in the chat box. Please share your feedbacks. Thank you.